So I'm very, very happy to be able to introduce Ingo Jaeckel from Riot Games to give our guest lecture of the year. So he's going to do a little bit of a history about his own experiences and talk a little bit more. And welcome. I'll give you the floor.
Thank you so much.
Oh, these are on now.
Perfect.
I was wondering, my voice did not carry as much as I thought it would. There we go.
I should also be unmuted in Zoom, so that should all
Yeah,
come
so
through.
we can record.
Amazing.
Oh,
Thanks so much. Thanks for your patience while I get used to this setup. This probably the first time I'm in the middle giving a presentation like this. So thank you. It's a little bit awkward, a little intimidating. We'll get through it. Thanks for coming. I wanted to do a bit of a different take today on some of those presentations you guys have maybe seen before. I'm Ingo, I'm a software engineer at Riot, and I'm actually going to talk a lot about the things that also have to happen around a game that you're working on. So, yes, I will talk about a little bit my own backstory, how I got into the games industry in the first place. I have worked on the games themselves, but right now I'm mostly working on a lot of the backend work that needs to happen to scale games. I'll get into a little bit of what that means here in a second, because there's a lot. And then, how are they actually built and released? Games are really complex. They're always changing. I'll pull back the curtain on that a little bit as well. And then I will pay attention to my time, but I'll try to leave just loads of time for questions at the end. Um, so um, yeah, the thing I want to start off with is kind of my own path into the gaming industry. This will be different for everybody. It totally depends on, I don't know, what you're interested in, maybe what you're studying, what you want to do, if you even want to work on the engineering part of the game or the design of the game. But I'm just going to tell my story. So I started out, did a bachelor and a master in computer science back in Germany, and there's loads there that I can unpack and talk about how that kind of helped me later to get into video games. But the one thing that made a big difference for me was really working on in my thesis on in-memory databases. So, this is a long time ago now, but at the time it was really, really cool that you could actually, for the first time, fit, I think at the time it was a terabyte into RAM, terabyte of data that you wanted to analyze for the company that's using the in-memory database. And so they were already pretty fast because you basically, in those databases, you compress all your data, you make it small enough that it fits in RAM, you get a lot of RAM, and then that already gets you pretty far. But we were looking at using GPUs to do even faster, like accelerate them even more. There's like I said, a compression step that you need to run kind of in the background as new data is coming in. And so I was looking at using GPUs for that purpose. How does that matter to games? Well, I think it was one of the largest systems and kind of largest amounts of data that I had interacted with at the time. And it really laid the foundation to work on something else, a different job, or actually do one of my first jobs, which was in air traffic control. It's pretty wild now in retrospect that me and a friend, we get to work in the space, but basically we built a system that is receiving weather data as just text and turns it into voice, turns it into speech. But then also, because the hardware constraints at the time were pretty crazy in terms of how this would be deployed near airports, we had to write some code that maps this stream of sound onto a specific channel on a sound card. So that it can be previewed before it's sent to pilots and then actually send it to a different channel that's used for actually sending real weather forecasts to pilots, which was, again, pretty wild at the time. So, and again, loads of things there that I learned, but the main takeaway for this talk is, those are massive distributed systems that like air traffic control and reliability, obviously, is really important. All those planes, like it's really, really important that all the systems supporting air traffic control, that it always stays running, even when like individual components are failing. So fault tolerance and just distribution in general. I just learned a ton about that by working in that company. Then a bit of a different spin, something else I was doing around a similar time was customer relationship management systems. So it sounds a little bit more boring, but basically this is like software that small and medium companies especially are using to, despite their size, run their business really well. And so from their perspective, even though it's not air traffic control, this stuff is really, really sensitive to them. It's really important. A lot of the time they only have a few people. They're trying to run their business. And so they're really leaning very heavily on this type of software. And again, me and a couple of friends, we did this as like freelancing jobs. We were able to go to different companies and maybe take a system they already had, migrate it to something else, or customize it for their use. So again, on a surface level, it sounds a lot more boring. Like there's a lot less at stake, but for those companies, you have to imagine the business would shut down if they can't use those systems for a couple of days. So again, like criticality was pretty high. The other thing I learned there was this is actually pretty performance sensitive, because the slower those systems are, the less productive your team is in the company. And so a lot of the work there we did, besides just supporting whatever flows they have in the company, is actually making it go faster. And so I did lots of profiling and kind of database related optimizations there. And that's why I highlighted Memcache, because this was the first time I really used Memcache in this way, as a way to not so much rate limit, but mostly cache all the interactions that they had with their database, which again, because they're running their business around this, made a pretty big difference. When you take all those three things that I talked about kind of in combination, line it all up, I think this was one of the reasons I was able to get a job at Electronic Arts, because I hadn't worked in the gaming industry. I really had no prior experience building games at all. But it turned out, and I didn't know this wasn't planned, but a lot of the tech stack was actually like very similar. Like they were building big distributed systems, and they were using things like Memcache, MySQL. Databases were super important. In fact, one tidbit that I can mention, one of my first projects working at EA was actually migrating from one database technology to another one. And one of the first big issues that I caused, wasn't the only one. One of the first big ones was basically losing player data, because the new database that I was migrating to basically behaved differently when it was overloaded. And the way the code was written, we basically reset players' progress when you overloaded the database. And previously, you could also overload the database, but basically, like the failure scenario had changed with its migration to this new database. And so the first thing I had to do was kind of data recovery and re-importing data and tracking how many thousands of players were impacted. So yeah, I definitely learned a lot going through that. The other thing that I'm highlighting there is this was the first job where we were using multiple cloud providers. So Google Cloud Platform and AWS. And yeah, again, that just deepened my, kind of forced me to learn more about cloud, and it was really interesting from that angle. And then, yeah, in 2018, applied at Riot Games. And there's loads of things, and I'll get into them a little bit, loads of things there that I learned. But the main thing I wanted to highlight for this presentation is all the games that Riot works on are very, very latency sensitive. And so this was the first job where I really had to be, everything that you're working on has to be deployed in data centers around the globe. So yes, we're using multiple cloud providers, but we're also in multiple regions around the globe. Okay, so the next thing I want to just touch on is some of the games I worked on. And yeah, I will not go through all of them in detail. I just I thought just wanted to zoom out a little bit and show kind of, if you're getting into the industry, sometimes you'll work on a game that you're very, very excited about, and sometimes maybe not so much. But there's also the difference between what the game looks like as a player versus some of the tech challenges that you are facing when you're an engineer on the team. So like I don't know, really like still things that I'm really proud of working on this Monopoly Bingo game, because this was the first game that I really built from scratch. I was with the team from day one. even though when you look at it as a player, you don't really, it's hard to see. It's hard to see to really have the appreciation for all that stuff that has to happen in the background. The one game I wanted to dive into a little bit deeper is Command and Conquer Rivals, which is really the last game I worked on at EA. Because this is a series that I'm really passionate about. I love this type of game. I love strategy games. And so I was just really excited to be part of bringing this game to phones. And this is also the first multiplayer game that I ever worked on. And so this is where the multi-region aspect comes in. At Riot, almost every game is like this, but you just, as an engineer, you solve very different problems when you're switching from something single player, maybe a little bit more casual, a little bit more forgiving, to multiplayer, where every little hitch, I mean, definitely every crash, but also every little hitch by a couple milliseconds really can ruin the game experience. And we'll get into this with some of the other games on the list, but that you might not have a game. You might not have a game if, I don't know, every other session you're playing, there's something that's adding friction to the gameplay. So with Rivals, it was the first time that I really was looking at things like picking between UDP or TCP WebSocket connection, and like really feeling as a player, feeling the differences, doing lots of load testing, so simulating lots of players storming into the game at a rapid rate, and then fixing all the bugs that we found in the process. So, and there's a screenshot there. I think it's still in the App Store, so you can still check this out if you're curious. So I'm touching on a few of those things already, but one of the things I wanted to speak to is why gaming is maybe a little bit different, or what are the types of things that are impacting the tech designs that I'm going to talk about, right? Like why is this different than any other maybe tech company? The one thing that I want to talk about there is really the development process, because and you will have come across this when you're working on your own games. It's really, really hard sometimes to find the fun. When I talk to people, sometimes they maybe get this impression that, like, what's so hard about game development? You have an idea, right, and you build it and you're done. But typically you build probably 100 games. You build that game that the end user, that the player sees, you've built that 99 times before, because you've been iterating and it was interesting, but it wasn't quite right. And so that really, really shapes the development process, working on a game. And so what I'm thinking about is like everything you build has to be able to change very rapidly, right? There's no such thing as a perfect design. The design is always changing, and you always, in practice, will work with game designers and product managers and other disciplines to tell you why the game has to change a certain way. And players as well, right? Players will give you loads of feedback, and that will, of course, be your main source of change as well. The games today that I'm talking about are also heavily just driven by the content that we release. And I say content, but it could mean new features in the game. It could mean there's a new game mode out that players have been on social media. They've been really, really hungry. They've maybe seen a game mode like that in other games, or there's a new map launch or skin launch or whatever it might be. And so again, from a tech design perspective, that means whatever you build has to be able to support your player count, maybe 10xing from Monday to Tuesday or whatever. Right, so you can't just statically figure out, okay, we need, I don't know, 100 servers to run this, and that's just how this is. We'll never need more than that. You don't know that, right? Your game might flop. Your game might do, I don't know, so-so today, but then you launch a new feature and it might really explode. And if your platform doesn't support that, then all those players just go to the next company. They go somewhere else, right? I mean, we know this as when we're excited about a new app or new game. If it doesn't work, well, we're just going back to our old game. So that's really shaping a lot of the stuff I'm going to talk about. And yeah, player expectations. Players have high expectations. And they should, right? Like, we're really competing. There's so many things people can do with their time. And we're really competing for that. And so you have to, even if you have a lot of experience in the industry, you can never take for granted that players will come. You always, I think, have to fight for it. And when you make mistakes, when you get it wrong, when you totally maybe misinterpret, you have your expectations how well something will do, but then you give it to players and it completely flops. You have to ask them why, right? You can't just expect them to love it. You really have to earn that trust. And especially for live service games that exist for a long time, it's a long journey. You have to keep earning that trust over a long period of time. And because the development process is so rapid, that's not always easy. I hope that makes sense so far. So now we're getting a little bit more technical. I probably, I don't know, some of this stuff will feel repetitive because I just learned or I just have seen some of your games. If you're starting out and you're maybe building just a single game that runs maybe on your laptop to start with, it's going to look something like this, right? I mean, you can have many choices. There's a lot of stuff you could do differently, but you'll have the actual core game. You'll maybe use either an engine you build or something that's just somebody else built, like Unreal. Unreal is really common in Riot, for instance, and many other companies. I've used Unity as well in the past. So something like that's pretty common. And then if you're using Unreal, you're probably using C++ for the actual game itself that runs on your laptop. Again, if it's a live service game, there will be some kind of backend service or services. I'm focusing on multiplayer games here. So I would distinguish between, you would have one part of your service or services that is focusing on the player-to-player interaction. So if it's some kind of real-time strategy game like Rivals, that's the part that's very sensitive to, I mean, in my case, garbage collection, for instance, right? Like when there's any hitching, any delays in performance, in this case of Java, that's the part where you're really noticing it and it's really ruining the experience. And then there's another part I'm calling it login service or metagame, all the things that have to happen around the game. So you want to log into the game so that you can continue your progress on a different device, different laptop, or when you add another platform later on, you can continue to play on your phone. For all this type of stuff, you need some kind of login mechanism. And then metagame is really everything else, right? It's if you have settings in the game, if you have progress that you need to persist, if you have a store in the game, all of those things fall under that umbrella. And yeah, as your game grows, there's a chat, there's so many things happening within that. So, but anyway, this is roughly what it looks like. If you are luckily, like you're really successful, you're growing, you want to build more games, you want to go to additional platforms, you're basically going through a transition that looks something like this, right? So you started pretty simple, not too many boxes. Even that can be pretty hard to achieve, but you're moving to a world where all of a sudden your players are spread across a couple games. Some of those games might be on all the platforms you care about, but some games are mobile only or PC only. And you have to adjust your all the tech that you're building, all the systems you have to adapt them so that they can support all those permutations, right? Like game 3 is on all platforms all the time. Need to support that. And game 1 is maybe the game you start with. And that still needs to work just as well, even though new games are already out and additional games are in development. So just to zoom into this a little bit more, basically what you're trying to do as you keep adding platforms, like mobile platforms, consoles, etc., just to keep the complexity as low as you can and not compromise kind of player experience, you're trying to split your backend services into something that's reusable. This is marked in red at the bottom. Something that's reusable and kind of game agnostic. The login service is a perfect example for this, right? Like typically, if you have many games, there should really be only one way to log in. You don't have to reinvent this. You don't want to burden whoever's working on game 4, game 5. You don't want to burden them with reinventing how login works. And the good thing about that part of your tech stack is you can actually release that very aggressively. Like I say here, you could roughly release this daily. We actually, luckily, like team I'm on, we release like hourly sometimes. So you can very rapidly get changes out to players. this can be very quickly evolving. So if you need to fix a bug, you can very quickly respond. The blue box is for everything that's like very, very game specific. And typically this will be the maybe the player-to-player features that you have. Like, I mean, in the case of Riot, some examples I can give is Valorant has very aggressive. Valorant is a first-person shooter game, tactical shooter, and so you have very, very aggressive latency targets, and so that's very unique to the extent to which they are aggressive. That's very unique to Valorant, and it's also the latest kind of game server that we have that works in this way, and so that part of the game will always be tied to the game. It will be game specific, and it probably has another a slower cadence, maybe something like weekly or bi-weekly. So what you're doing there with this very simple split is you're saying, okay, we take a couple of our engineers and they're just focused on every day just making this platform better and better and better, so that as we go from game 1 to game 10, hopefully we make it easier and easier for us to make games and then make the experience better for players, so that when the next game launches, if you have some cool features in one game, we can ship those cool features really easily in the next game. One other thing I want to mention is this like tiny red box at the top there. A lot of the games I've seen today, maybe all of them actually, they're all like single player games. And so like in a way, the box there that I'm talking about is like, you'll probably have some kind of library that you're shipping with your game, shipping with the build of your game, that makes it, for the game team, makes it easier to talk to this entire platform that I'm talking about. So if you want to log in, how do I do it from Unreal or from Unity or from my custom game engine, right? This library will help you to do that. So that, again, as a game team, you can focus on whatever you see on the screen. You can focus on that new game mode that you want to add, or whatever separates you from loads of other games out there, right? That's what you want to be able to really focus on the game team. And that's why we're giving you this red box there, this library, to make it easier to talk to all this growing platform. And so that sounds great, sounds like it can help you, but the reason I'm calling out the different cadences of releases is because it's integrated in the game that you're shipping to players. It's a lot harder to actually update because, again, multiple platforms. If you're running a game on console or on mobile, you actually need Sony and Microsoft or Apple's approval to get the update out. So if there's a bug today in, I don't know, Teamfight Tactics and mobile, yes, we can fix it immediately, but we actually need approval from Apple to get the new update verified, and then only then it's going to be in the App Store. And it's much worse on console, where there's a lot, much more delay. And so there's this weird lag between, yeah, I can be on a team that works on the platform and I can get an update out in a couple minutes or like in the day where we find the problem, but only until it might be weeks or months until the game team can actually pull that update and get it released to you as a player. And so backwards compatibility is super important. We have to fix as many things as we can just in the platform on the backend service and kind of hide the bugs as much as we can, so that you don't have to have this library update in the client. And yeah, tech choices. Yeah, I mean, there's going to be more of everything, basically, is the short version. So probably if you have, as you're trying new games, maybe those games are more or less kind of latency sensitive, or maybe you want to try a new language. You're just going to use more programming languages realistically as you grow. I put a couple examples up on the screen, some of the languages that we're using. And then the reason I put Redis up there, Redis is something you would use for definitely for caching, but also for things like rate limiting. I mean, players or attackers will do all kinds of funny stuff. They will write scripts against your game server to give themselves things in your store. They will try to hack you. They will look for vulnerabilities. They will just try to DDoS your service, right? This happens all the time. So Redis wouldn't be the first line of defense. There's higher level stuff that would usually protect you, but Redis is one of the things that we use as like maybe second and third level of defense to just protect our services from things of that nature. And I think AWS wasn't on the slide, but probably as you're getting this complex, you probably would use some kind of cloud provider to host the game. The one other thing I want to mention, I've touched on this before, is if you actually you're so lucky that the game is actually globally successful. This entire box that I mentioned here with all the different components, well, you need to basically wrap that up and find a way to get that deployed in data centers around the globe. It's a lot more complicated than this in practice, but that in a nutshell, that's what you need to do. So again, using the Valorant example, I think one of the latency targets when we launched Valorant almost 6 years ago was, I think, 95% of the ping times need to be below, I don't know, I think it was around like below 40 milliseconds or below 30 milliseconds. So that dictates, okay, you have to have a maximum distance between the data center and the player, otherwise you can never achieve those latency targets. And so in some regions, you'll get that right. The distribution of your player base will be such that there's always going to be a close data center. Like when you're playing Valorant here, you're probably going to be connected to either London, UK, or Frankfurt in Germany, or Paris. So you're going to be connected to some of those because we have those options, right? So we're kind of trying to match the population of the player base that is online right now. And we're trying to find people who are as good as you are, but we're also trying to give you the best ping possible. So you could have more red dots on the screen, but the more often we're deployed, the closer we are to players, the smaller the player base is getting that you're matched with when you're playing the game. So the solution wouldn't just be, oh, let's just buy lots of buses and have like mobile data centers. They need to be far enough away so that you have a large enough radius for loads of players to choose from. Getting to the end here. So the one other thing I want to touch on, because we're talking so much about, I don't know, the complexities and also the rapid rate of change, is actually how do we actually get a lot of the changes that we want to make? How do we get those out to players? Yeah, I mean, this would be worth its own presentation, but in a nutshell, the answer to that is pipelines. So again, all the different boxes that you've heard me talk about, we kind of wrap all those up in what we call a test environment. Then we connect those test environments with quality gates. This roughly looks like this. The engineers on your team will kind of create a new version of the game, of either the game itself that you're interacting with as a player, or of the backend services that make it all work. And yeah, they release a new version. So, I mean, to be more specific, they would maybe, if you're using Git, they're making their commits, they're pushing those commits to Git. Then this will all be built and deployed in the dev environment. And then hopefully a largely automated set of tests will verify, would this work? Would this work for real players? There's a lot of things that we do there. We have like thousands of tests usually that would run every time this kind of test environment is updated. You would also do some amount of manual testing at that stage, but probably the really early in the pipeline, you would just use automation really aggressively and just test kind of everything in the game automatically. You would also do things like scale testing. So classic example, the memcache piece that I mentioned, if you're trying to do an optimization, and you want to test that optimization, you're pushing to this dev environment, and we're running a load test where we simulate, I don't know, a lot of players using the system. So that gives us a very strong signal very, very early on and actually verifies, is it actually faster or have we made it much, much worse? Because a lot of the time we do. And yes, as you progress through this pipeline, hopefully, like the idea is you're catching more and more regressions early on. So as you progress through the pipeline, things should get more stable. And then as the closer you get to the player, the more you would use other things like focus more on balance of the game. And does that actually feel right? Maybe it's functionally working, all because of all of our tests have been passing, but it's just not the right change. Like we actually detect that we don't want to ship this to players, again, not for functional reasons, but for it's just not the right game design after all. Even though we've done other testing beforehand, now that we see it before we ship it to players, we actually pull the ripcord and just go back to the step one and release a different type of change, right? That's really important because again, the timing and the cost of the different stages varies a lot. You can typically update something like a dev environment in seconds or minutes, versus actually releasing to players is something that can take a very long time. The library example that I mentioned, where you are updating this SDK, this client-side SDK, yeah, it could take months. Like you could make a bug fix today, and then maybe you review it with your team, but maybe it takes Microsoft a week or longer to actually give you the thumbs up and allow you to update the game on console. So that means also that it's really important that you actually are confident and that you have done all your testing up to this point, because if Microsoft approves it, but then you still find a bug that Microsoft hasn't caught, then you still can't actually launch it, and you've lost a week at least. So want to wrap up, and then I want to turn it over for some questions. But the thing I want to leave you with is there's definitely many paths to the games industry. I try to go back and find what's the common thread maybe, or what has helped me along the way to get into games in the first place. But it definitely wasn't planned this way. It just, this is like, I had to go back and see what happened and what probably led to me getting a job initially. But there's many different angles to this. There's also, I tried to talk about this, there's so many different roles in every games company. Even like within engineering, there are tons and tons of different ways, different work that needs to be done. Yeah, I love talking about this idea of finding the fun. This is very real. We don't know when we're setting out to build a new game, when the game is in research and development mode. It's only really at that stage we're trying to find like what actually makes it fun, and that does take years. And yeah, and then the two main things that I touched on to make games scale just very recently now is kind of building a platform, building that out, and then release pipelines with really good quality kits. And that's it. I'm happy to answer some of your questions.
Thank you. Ingo, and go out to the crowd. This is the problem with the room like this, that it's bear with us, because there is a bit of a circle we need to do when people put up their hands for questions and that sort of thing. I might kick off with just one little question, because it's one that I sort of was like, I want to know the answer. Yeah. So when you actually, let's say the library is actually in the actual game code shipped with the console, what happens when there's like a 0-day bug, like a 0-day hack that like, we've made a mistake and it will break your console? Is there like the red phone that you can like pick up and go, lads, you've really got to do this quick, because it's out there, somebody's found it on the web, they now can sideload on a PlayStation 5?
Yeah, so you have no idea how many different I don't know, ways of measuring severity we have in the company. It's pretty funny actually, but we basically, if it's something like this, there's like legitimately a security issue. First of all, like we were actually talking about this, like we have security teams, which hopefully they would have been involved in kind of auditing and spotting this, hopefully at like an earlier stage. Yeah. But if they didn't, if this is putting players at risk, we can't go live. Now, I will say there are lots of caveats to this. My team actually, one of the things we're working on is it's something that sounds really simple, but it's actually pretty hard to do. It's pretty significant, pretty complex, like feature toggle systems. So typically, those kind of security issues, they typically are focused on, I don't know, maybe one feature of your game, maybe like a part of your store or part of your login. And so we have ways to, again, on the back end, just say, okay, let's just not allow this payment provider or this way of logging in or whatever, so that we can actually launch the update for the game, but this part of the game is just going to be disabled. The payment provider thing is a good example because like I had no idea how many permutations there are of countries and payment providers, and there's always around the globe at any given time, there's always some permutations that don't work. And so we automatically now turn those off, and so that you can still go to the game, everything works in the game, you just don't see what's broken.
Yeah.
So I think we would do something similar there. If we can, we would turn it off. Ideally, we would have already caught it, but if we didn't catch it and we can turn it off, then yeah, we wouldn't go live with it.
So it's a floor if wants to ask questions.
Yeah.
With crunch culture being so normalized in the games industry, have you, many jobs felt it? And if so, to what level of that affect you?
Sorry, I'm smiling because we're starting off in the deep end. I like it. Talking about crunch in the first question. Gosh. I would say at the very beginning, yes. But it was kind of a combination of, look, like historically, yes, like it's well documented. I'm not going to pretend it's not there. But I also really had no clue how I want to work, what is important to me, like in my job or in life. And probably one of the reasons I talk about architectures now in retrospect is a lot of those things are designed for you not having, so that you don't have to crunch. Right? The reason we have those pipelines and the reason like build times and all those checks are so important is it gives you predictability. Like the main reason I think, or not, a lot of the time people crunch because you don't have that predictability, and so like you're never done. Like you keep working on it, but there's always maybe new bugs and things like that. So a lot of the thing that we're doing with the pipelines is take that ambiguity out of the development process and make it a bit more predictable. Other thing I would say is sometimes the fact that you're crunching can actually be an indicator of just bad game design. Like that's definitely something I've seen, especially at the beginning when teams are not sure. Oh, what do we want to build? We'll build everything. And I mean, those games can take like 10 years to be built and then they're a flop on arrival. So, I mean, I've learned a lot just how I can cope better with it, but as a person, but also, again, a lot of those things that I'm talking about, they're there for a reason, right? They're there also to protect the team and help to give us that clarity that, because a lot of the time when you're crunching, you're chasing the wrong thing anyway. Like sometimes games are just, they're much too big. There's loads of stuff there that nobody's ever going to interact with. And it's maybe not fun. Like maybe it would work, but if it's not fun, then what's the point? Any other question? Yeah, go for it. Sorry, I saw him first. Yeah.
How does Riot Games growth compete from different? And what are the biggest technical challenges?
Sorry, did you say anti-cheat?
Yeah.
Yeah. Great question. Definitely not my specialty, but I can call out some things that I'm familiar with. So have you heard of Vanguard before? Does that ring a bell? Is that what you're asking? Okay. You'll probably know more about Vanguard than me. But so if you're not familiar with Vanguard, one of the things that was, and I mean, it's very integral to Valorant is as a game is competitive integrity. And definitely not ready today to talk deeply about competitive integrity in Vanguard, but the basic idea, the basic premise is it's not good enough to have the game itself that runs in user space, right? It's another process on your operating system. It's not good enough to have that process itself do the monitoring of what is installed, what are the tools that you have, what maybe cheating tools are running right now. You actually, other programs can hide from that and can make it invisible that you're using those tools. And so that in the past has broken competitive integrity a lot because players would play other games. I don't want to throw anybody under the bus, but basically like you as a player, you would have a bad experience because you are convinced that you only lost because the other person was using some kind of tool that couldn't be detected by your game. With Vanguard, the idea is, well, let's move that detection from user space to kernel space. And so it behaves a lot more like any of your drivers or anything that's created by, I don't know, Apple or Microsoft that runs at kernel level, like you have that level of visibility and trust. I mean, one of the things, because it's not my area of expertise, I can mention is very, very smart people are working on it. And it's again, I talked a lot about architectures today. It's something where you have to come up with an architecture that is resilient to failures, because there will be bugs in this. And so you do all the audits and all the architecture reviews and things like that, and bug bounty programs and stuff like that to make sure you can trust this thing, so it cannot be abused and it finds all the problems. But so with great power comes great responsibility, is what I'm talking about, right? Like we really have to. This is a pretty big burden to say to players, oh, you can only play our game if you install this kernel level thing that will make sure that nobody else can cheat and you can't cheat. So I apologize that I can't go into details because I literally don't know, but it's definitely the only part of that I have seen is kind of the services side where we analyze the traffic, right? It is actually really cool how we've been able to now the learnings that we have in Valorant, how we're able to put that into other games. So League of Legends is benefiting from some of the work there, and all the new games that we're building. Like everybody, right? You want to know that you've lost because the other person was better than you, not because they have been cheating. And so, yeah, I would love to just maybe share some other resources with you that go more into detail. But those are some of the highlights, like things that we do to make sure it will actually work and make things better, and not like basically anything running kernel level, if it crashes, really brings your whole system down. So that's a lot more serious engineering than what I do now. Right. Yeah, go for it.
Question. You said you do a lot of like automated testing. How do you know about like the amount of interactions that?
Good question. Yeah, that's a whole nother, if you're looking this up online, there's a whole discipline called test engineering. I mean, now with LLMs as well, we're at this point now where you literally can teach LLMs to play the game as well. So that's a whole nother level. But I don't know. A simple example that maybe illustrates how we're doing it is if you have browser-based games, like Flash-based games, right? You can literally use tools like Playwright, for instance, really good at it to like, okay, have a test where you're clicking on certain spots in the game, like certain coordinates, or if it's HTML, you can like find buttons and stuff like that and click on buttons and then see what happens. That's kind of the visual way of testing it, right? And then like tools like Playwright will like record your screen while you're doing it. So 99% of the time it's passing, but then the 1% of the time that it's failing, you do get a video. So as the engineer, you can be very hands off and you just wait for the video to come in for the one time where it failed. And you see exactly, okay, I don't know, at 3 minutes into the tutorial, the game crashes here, or the button is placed. If you play it on a phone with a poor connection, right? Like we do those very, very big matrix tests where you do the same thing, but you do it in very different conditions. And yeah, you get videos in the case of Playwright. The other much faster way to do it is if you don't run the test with the UI, right? Like you can, I don't know what a good example is. Like this, a similar thing would happen in, or the idea would be used in something like robotics, where you don't always want to actually move the robot. You just want to send the input signals and verify the output signals, right? So you could test purely, the test could pretend to be the game client, and it could send movements, and you could assess, okay, does the game state change the way I expect it to change when the characters are moving like this on the screen or are fighting each other like this, right? So you don't have to have the actual visual representation up and running. You can, but it kind of depends on what you want to test. Yeah, you're basically at that level of testing, it's probably going to be more rapid, and you can do things like load testing more easily, but you're mocking the client, right? You're pretending to be the client, or so one of the things that I did, so in CNC Rivals, we did, like, for me, this was the biggest load test that I did ever, like up to that point. We kind of simulated 1.3 million concurrent players, and you couldn't really do that if you want to launch an instance of Unreal 1.3 million times. Like you don't do that. So you use a model where, okay, there are no pixel, there's no visual representation, there's only movements on the screen, and like this person is winning or that person is winning. And so in that setup, you can test like massive numbers and like really, really aggressive load patterns, if that's what you're interested in. If you're more interested in, does this crash on a low-end phone? with a poor connection, then yeah, you run the whole game. So there's loads of different ways of doing it. With Android, at the time, what I was doing was the clicking on screen type of stuff, which is you test the entire tech stack. It's very integrated, but it's not very scalable, right? You need real devices or emulators, and it just takes a lot more time for the test to run. Yeah. Yeah, go for it.
To specific like game teams in a larger company, would you still have kind of hybrid tech stroke game designer roles, or would it be a lot more specialized nowadays?
Gosh. You're probably not going to like the answer. It's probably both, because I'm seeing on one hand, you need a lot of just deep experience when things get hard, like when like some of those bugs we're touching on. It is like specialization does help you. And I mean, we could talk about LLMs all day long, but for a lot of things, there's just not enough training data. And I mean, for a lot of stuff there is, but like some specialization, you just you have a little bit more job security just because like those kinds of things weren't maybe done in public as much, and so the training data isn't as big. I have now more and more seen when somebody just has an idea and they're not technical, yeah, they are using LLMs, of course, to get some of those ideas prototyped much quicker. So that's not, I don't think it's a bad thing. So we are seeing designers, product managers who have ideas like for what something should look like. Like we give them some kind of sandbox essentially where they can try an idea in a safe way without breaking anything. And so that is also happening in parallel. So I think specialization is still really valuable. But we also all know like the one constant in tech is change. So I have seen it being really valuable, but you also need to be careful that you're not specialized in something that becomes obsolete. So yeah, not a great answer, but that's kind of my take on it. I think when you're starting, my opinion, it doesn't really matter. Like if you feel really passionate about something and you show that you can learn, you don't need to be specialized in exactly the kinds of things. Like companies, right? When you read a job description, yeah, there's going to be 20 tools and techniques and languages in there, and nobody has done all of those things. And if they do, they probably want to be paid more, right? They probably don't want to take this entry-level job. They want to have another job. And this is kind of the reason why I talked a little bit about what are the different, some of the technologies that I learned along the way, which EA in this case, their tech stack happened to also rely on some of those things. And then I was able to talk about only those, that subset, but I could demonstrate, I could learn the rest. Yeah. That makes sense.
In time. Yeah, I've only one last question, just as kind of a final one, maybe. Sure. Where do you feel the LLMs are going in terms of games development? Is this something that you think might allow smaller teams to kind of compete with larger groups? Or again, like a global game like yourself, is just so much infrastructure around that's actually needed to be done? How do you think that's progressing to the extent that larger groups like Riot and other games have such a lead because they have the tech stack that it might be actually harder for people to come in because everybody can use the LLMs, both big and large, going through. So how do you see the impact in the industry a little bit? Again, very theoretical. We won't hold you, ask you in 5 years. That's not what happened.
Yeah. I don't know. I don't know if this is helpful, but I have some other slides. Yeah. This is all like, you can find this stuff online. It's all public, but around the time Valorant was launching, we did a couple of kind of tech talks where like, I mean, basically like before it launched, like it was in development for like more than 5 years. And this is taken in one of the videos where we'll talk about the netcode. So the reason I'm giving all this kind of backstory is like, on one hand, I do see there's certain activities you have to go through, certain things you have to do in the job where something like LLMs are like, it's definitely, it does make a massive difference. Like it does speed us up in a lot of ways. That said, there's a lot of cognitive load. There's a lot going on. I mean, this is the netcode example where we're in this video, we're talking about peaker's advantage and what can we do to reduce that as much as possible, again, for competitive integrity. And the problem that one of the challenges, right, that again is well documented, it's not so much that could you have done what the LLM does now for you? It's more, are you asking the right questions? If you don't know that netcode even matters in the first place, you're not gonna ask the LLM to write netcode at all or in this way or address peaker's advantage. So you still puts more and more burden on you to do the initial research well. And again, ask the right questions along the process. And if you work on a game for a long period of time, like again, we talked about crunch a little bit. This is an issue now. I think it's still an issue with LLMs that a lot of the time you work on the wrong thing. Another example I think is like this is, I think, from a similar presentation, a screenshot about profiling Valorant, like as you were looking like in the game as you're moving around. We're talking about things like, okay, how much time do we have to do certain things in the game? And because basically people were surprised, like how are you optimizing this so aggressively? And what are all the call hierarchies looking like for the backend code, the front end code? If you've never built a game before, you wouldn't ask any of those questions. So yes, it's incredibly powerful. I think deep like knowledge as an expert still is really important, because otherwise, yeah, you're not gonna put certain context in the prompt that is needed to give you a good outcome. Or if you're using I don't know if anybody's using kind of like open weight models, you're not gonna fine tune the model. You're not gonna provide the right sample data either. So yes, the activities are changing, and like no doubt this stuff is really, really powerful, but you do need to do the work to actually understand how does this stuff work. Don't need to do that work, like enough work to then know to ask those kinds of questions and think about what is my budget for each frame, and then within the frame, how much time do I have to progress the game state versus do the rendering? Like there's a lot of stuff happening around the game itself that that takes teams of people to really get. And then you need to go do the testing, right? It doesn't help any of the players if you have the perfect technical system, but the game isn't fun. So it definitely helps us with iteration. But those problems still exist.
Slide. Should go back to it.
Yeah.
Am I interpreting that correctly? Of the one on the right essentially is everybody is essentially getting the person in the right place, while the one on the left, some people are seeing them early in the red and some seeing them are late in the blue.
Yep.
To go on that. I don't know if you're familiar with I'm trying to remember what it was called. Quake World.
Yep. I played loads of Quake for sure.
Yeah, but Quake World being one of the first netcode enabled. Now, in fairness, again, not saying anything bad about UCD, but University of Limerick was one of the first places in the world that used to host the Irish server. Because again, the same problem you have there. And this was to understand at that stage, they were allowing up to 50 to 100 millisecond lag. So you literally could shoot somebody and then the game goes, actually, I'm running the server. He was actually here. You didn't die in your game. And he pops up alive again. So these were the early days. This was over 25 years ago. But this is this is the first time I've kind of gone, I now want to play this game. Because literally seeing that level of netcode to get that sort of approximation for lag is just amazing.
The one thing I love that they talk about in this short video, is it's a simple idea, but like until you write the code for this, it didn't really click with me. From the server perspective, by the time the server registers, oh, Ingo shot at this other player at this angle, the time on the server has already progressed because my network packet that sends this information to the server is traveling. And the worse my ping is, the more the server will already be in the future and has to rewind the game state to 70 milliseconds ago, which doesn't sound like much, but the games are so competitive and there's so many players in the game at any given time that this stuff really decides who wins or loses. So yeah, there's loads of, and again, you need to test it because like I said, we've kind of built this game many times over. It looked very different at the beginning, and you want to be able, if it's a live service, you want to be able to sustain the game for a very long time. And so it's not good enough to just build it once, build a prototype. You actually need to figure out, okay, and I haven't really talked about this much today, but how can we run it not just globally, but we also are operating the game in China, where it's deployed in a very different way. Nobody really outside of China has access to the, so you have to find a way, okay, how can we build this in such a way it can just be deployed in China and operated, and we don't have to touch any of it, right? Like it needs to work in a completely different context on a different cloud provider, and has to work just as well. So there's many things like that I think are just, they're tricky, even if you have, well, with or without the LLM support. Yeah.
So I'd just like to thank you again.
Thanks so much.